The direction of rotation is decided collectively by the positions of drones before the circle formation. If drones receive an external command to change the shape of their formation, they are able to reorder autonomously into a line, segment, or a grid.
Drones are most commonly associated with war, terrorism, and cyber attacks, but drones can be used in more peaceful civil applications as well. In the century of global warming, low-cost environmental or agricultural monitoring is a must. With a flock of drones, you can create a self-organized monitoring system from the air, or you can even deliver food or mail.
Indeed, studying the flock of robots, of drones, has allowed us to understand much better the group flight of birds, for example.
I'm Bernard Marty. I am professor of geochemistry at the Université de Lorraine, and I'm doing my research in a research center called Centre de Recherche Pétrographique et Géochimique of CNRS and Université de Lorraine. My main field is cosmochemistry and geochemistry. That is, we are using physical and chemical methods to investigate the state of the matter in the solar system and on Earth, and to understand better processes that led to planetary formation and to the evolution of our planet. One thing we really don't understand is how the Earth that was born during collision, very high temperature melting, evolved towards clement conditions, that is allowing to have liquid water, for instance, allowing to have a self-replication of some molecules that eventually led to the emergence of life. Another planet like Venus, for instance, presumably evolved in a similar way as Earth. It is about the same size, it's about the same location in the solar system, not exactly, but grossly. But on Venus, you have a temperature of 450 degrees C at the surface. You have a pressure of 80 times the atmospheric pressure on Earth. So you cannot have any life developing on Venus. But on the Earth, the condition evolved in a way that it was possible to get liquid water and therefore to have life. So this is really challenging to understand why two planets like Venus and Earth evolved in a very different way, and why, presumably, only life exists on Earth in the solar system. What we learn from the past is that probably, or most likely, greenhouse gases has been playing a key role in maintaining clement condition at the Earth's surface. And this was already the case probably a billion of years ago. We have some evidence that the climate was warmer than today because there was more greenhouse gas like CO2 and CH4, despite the fact that at that time the sun was less energetic. But even so, the Earth was not frozen. Why? And the answer is probably there was more greenhouse gases. So by studying the past, we learn about how greenhouse gases are regulating the climate. We had some glaciation 15,000 years ago, but the bottom line is that we're injecting a lot of CO2 into the atmosphere right now through the human activity, and we are reaching CO2 levels that may compare with levels in the past that allowed the Earth to be ice-free. So there is a probability that now the human activity is really injecting a lot of greenhouse gas that may lead to a global change of the climate. And this is a very serious thing to think about. We are working at events that took place something like 4.5 billion years ago. That's a lot. But geologically speaking, it's an extremely small interval of time. to have been developed